exporting, converting, importing, and comparing objects. In this nugget, we're going to look at some different ways of getting data into and out of Windows PowerShell. We'll look at exporting things to a CSV, separated value format, and importing things from a CSV file. We'll also look at something called a CLI XML import-export. That's Command Line Interface Extended Markup Language. Some of the uses for that are really cool, including the ability to compare collections of objects. And finally, we'll wrap up by converting some objects into a cool-looking HTML report. Let's start by looking at how to get objects out of Windows PowerShell and into a CSV file. One reason you might want to do this is because CSV files are a format that programs like Microsoft Excel can read quite well. For example, if I wanted to get all of my processes on a server and maybe on a day-to-day basis at the same time every single day, put this information into a CSV file so that I can pull it into Excel and do some charting on virtual memory utilization or something else like that for trending purposes or maintenance purposes or whatever else. Well, doing that's really easy. Just pipe it to export CSV. Give it a file name, prox1.csv, and there you go. It's all done. We'll take a look at this in Windows Notepad so that you can see what the final output looks like. You can see that one of the things Windows PowerShell is doing is putting this type information. This is just reminding you and PowerShell that the objects contained in here came from a system.diagnostics.process. This line is preceded by a comment character. Most programs that import CSV files, including Windows or Microsoft Excel, will ignore this line. However, if you look at the help for export CSV, you see that there is a parameter called no type information. If you specify that parameter, it won't include that type line. So if you're having something that's having a problem with that first line, that's how you get rid of it. The next line is simply the column headers. Each property of the object became a column in this file, and so all the property names are the column headers. And everything else is just the actual data. There's one line for each object or for each process. You can see there are the process names, CSRSS, DNS, DWM, and so forth, along with every other piece of data. Quite a bit of data. You'll notice where necessary that Windows PowerShell automatically wraps things in quotation marks. So it's really easy to then bring this information into something like Excel, either for charting or graphing or long-term use, or maybe you want to import it into a database like Access or Microsoft SQL Server. CSV file is a really easy format to share between a lot of different applications, and that's one of the reasons that CSV is built into Windows PowerShell. Importing information from a CSV file is just as easy, although it can be a little bit tricky to figure out what PowerShell is doing. So let's kind of take a very simplistic CSV file with a column called 1 and another column called 2, and then two pieces of data in it. Column 1 will be A, and column 2 will be the number 1. Column 1 will be B, and column 2 will put the digit 5. So when you import this into PowerShell using the import CSV command, PowerShell is actually going to construct two objects. It'll do one object for each line of the file. Each property of the object will correspond to one of the columns. So each of these two objects will have a property named 1 and a property named 2. If we were to represent the first object as obj1, then we would see obj1 dot 1 contains A. If the second object were $obj2, then obj2.2 would contain 5. So with that out of the way, let's take a look at how it really looks in the shell. I have a CSV file here called provision1.csv. Let's just look at that file by itself to see what's in it. Provision1.csv contains several lines of data. You can see that there's column names, first name, department, city, last name, logon name, and so forth. And then there's roughly 10 or so lines of data. So let's take a variable, $, well, we'll call it $imported, set it equal to import CSV C provision1.csv. Now that will have imported several objects. Remember that each line in the file becomes an object. So if we just look at imported, we see all these objects. Notice that there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 properties, which is why these weren't displayed as a table. I could pipe those to format table to force them to be displayed as a table. So let's just take a look at the first of these imported objects by referring to index number 0. So imported 0, the country property is Japan. The fax property has a phone number in it. What about a property like first name, where the column in the file actually had a space in it? We can't just refer to that as with a space. Instead, we need to put the whole thing in quotation marks so that it can actually refer to that property. So it's okay to just put the property name itself in quotation marks. So that's how you can read through. Now, if we wanted to maybe loop through each of those and do something to each one, we could take imported, pipe them to the for each object commandlet, and then do whatever we wanted to do for each of those objects. For example, maybe we want to display the current line's first name property using the toUpper method. And that'll show everyone's first name in all uppercase characters. So that's how you could run through each of the objects and do something with each one in particular. So the ability to export to CSV and the ability to import CSV is really useful. It allows you to take data out of Windows PowerShell, reuse it in multiple different places, and take data from other sources like Access databases or SQL databases that can be exported to CSV and bring those into Windows PowerShell and do something with that data. The other way PowerShell has of importing and exporting data is called a CLI XML file. It stands for Command Line Interface XML. Let me run get service. I'm going to pipe it to select object and just select the first two objects and then export them to a CLI XML file. We'll call it services.xml. Now let's just see what the actual raw text of this looks like. It's an XML file. It's not meant to be easy to read, but here's a really cool part about it. Let's say that sometime early in the morning I wanted to see what processes were running on a particular server. So I write a little PowerShell script and I schedule it to run at 3 a.m. when I'm at home nice and asleep. And all it does is run get process export CLI XML procs.xml. Now it's going to take a few seconds to run because the XML it has to construct is pretty complex. Now I come in on my own time. Say I stroll into work at a nice casual 9 or 10 a.m. and I want to see exactly what processes were running on the computer at that time. Now just to prove a point, I'm going to launch a couple of miscellaneous processes on my computer right now and just leave those running. And now I'm going to run import CLI XML and import that same procs.xml file. You can see that those display as actual processes. We're not looking at the text. This isn't the text that's in the file. In fact, let's use this copy of Notepad we have open to look and see what's actually in that file. Procs.xml. This is what's in the file. So when I ran import CLI XML, it actually reconstructed the original process objects using a process that Microsoft.NET Framework calls deserialization. Putting them into this XML file was called serializing them. So we've deserialized them and recreated these objects. You'll notice that Calc and Notepad aren't on this list. And that's because these are the objects as they existed when the original export was run. In our example, this would have been at 3 a.m. And this isn't just a list. I can import those, sort them on virtual memory in descending order, select just the first 10, and let's say format them as a list, just including the name and ID. And that's exactly what I get. This import CLI XML is actually reconstructing XML into process objects. In fact, if we take that import and we run it to get member, we can see that we've got all the same properties of a process object. And the process type is still a systems.diagnostics.process, just like if we ran get process. The difference here is that these have been deserialized. And the one thing they don't have are the methods that normally come with a process object. So we can't do anything with these. Now, there's a couple of interesting ways that you can use this XML capability, the CLI XML file format. One of the things you can do is use it to create baselines of your computer's configurations. So to demonstrate this, I'm going to close Calculator and Notepad, and I'm going to run get process again and export it to a CLI XML file. I'm going to call this baseline.xml. Let's say that I've gotten this server configured exactly the way I want it, and I know that the processes running on it right now are the only processes that should ever be running on it. And if something else is running, then it's a problem. So I create this baseline file. Maybe I drop it into a change control thing like Visual Source Safe or CVS or Subversion or IonForge or something like that, so that that baseline is available to all the administrators, and if anybody overwrites it, we can still get back to this original version. Alright, now let's say I come in a month later and I want to see if my server still matches its baseline. Well, I'm going to run a couple of other processes, and obviously if there's just extra windows on the screen, it's pretty obvious. But maybe it's not a windowed application. Maybe it's another service that's running that's been installed. Or maybe it's a Trojan, a virus of some kind, or a keylogger that's been installed and is running on the computer. Here's what I'm going to do. I'm going to run the compare object command. And actually it has a nice alias called diff, and we'll use that instead. I want to compare the results of get process, in other words the current processes, with the results of import CLI XML baseline XML. So I'm going to take the current processes and compare them to what the processes were in my baseline. And I'm specifically going to ask it to compare the name property of these processes. Okay. Notice that the current processes are on the left of the equation and the baseline processes are on the right. This is indicating that on the left side I have Calc, which didn't exist, and on the left side I have Notepad, which didn't exist on the right. So it's showing me a very simple way of seeing the differences. Now here's what happens if I don't specify a property to compare. Diff is going to try and compare each and every property of these processes. Now processes as objects are constantly changing. They're always using a little bit more or less memory, or they've picked up a few extra handles, or their CPU time has changed. So when I run it this time, every single object is going to show up as a difference, and it's going to happen because some of those other properties have changed. That's why I specified a property. Let's do this whole exercise again just to make sure it's clear, and this time I'm going to use service objects, because service objects don't have any numeric properties that are constantly changing and adjusting. So let's get all the services, export CLI XML to baseline.xml. I'm actually going to just overwrite that old XML file since we're done with that example. And this time, let's close Calculator, close Notepad. Those won't matter since those aren't services. But let's definitely go in and stop a couple of services. Let's see if there's some services we can safely stop here. Let's stop service name bits. And maybe let's find another one that we can stop. How about WinRM? Stop service name WinRM. Okay, so now let's run a difference of the current services compared to import CLI XML baseline.xml, and we're just going to let it compare the entire object. Actually, it turns out a lot of different things changed. So maybe we just want to compare it against a particular property like status. Well, look, there were definitely some changes there. So we could then go in, dig a little further, find out some things that weren't. But what this is showing is that we had a running property on the right side in two instances and a stopped property on the left side. So this represents the two services that were running, which are now stopped. So we could then go in and select the names of those using another commandlet to dig a little deeper. But being able to compare objects like that is really a big benefit of being able to persist objects in those XML files. Here's one last advantage. Let's say I want to get event log from the security log, and I want to grab the newest 20, but I'm going to export those to a CLI XML file called events.xml. Now I can go email that XML file to a colleague, maybe someone who doesn't even work for my company, to maybe share some diagnostic information about a problem I'm having. That person could open up Windows PowerShell, say events equals import CLI XML, import that file, and then look at the actual event data that I'm looking at and manipulate it. Okay, you know what? Let's format this as a table. Just look at the source, the time written, and perhaps the index number. So they have the ability to sit here and manipulate it with me. Maybe through an instant messaging session or on the phone, we can communicate about what we're both looking at, and I'm not trying to read this information across the phone. It's a great way to actually transmit that and share it with someone. Of course, another great way to share and present information is the HTML format. Here's a fun little trick. Let's run get wmyObject win32 service. We're going to retrieve all the service objects. The reason I'm using this instead of get service is because I need to use a piece of information, the start mode, that get service doesn't expose. I also like get wmyObject because it allows me to make this work against remote computers just by providing the computer name parameter. For now, though, let's sort of prototype this and get this working just on the local computer. I'm going to filter this down so that only those services which have a start mode equal to auto and which have a state that does not equal running. In other words, services which are set to start up automatically but which are not currently running. Okay, a couple did come through. WinRM, which I just stopped, and this TBS. Those are both services that I should at least look into. I mean, they are set to auto and they are stopped. One of the reasons for that might be that they tried to start and ran into a problem, or that they've been improperly stopped by another administrator. But maybe this is something I really need to look at every single day, and I don't want to have to come down in here in the shell to do it. Maybe it's something I want my help desk to look at every day. So I'm going to take that information and convert it to HTML. And just by hitting enter, oh, well, it's HTML. Maybe I actually want to put that in a file. So we'll out file badservices.html. And once it goes out to a file, let's actually just run badservices.html. This will open up in Internet Explorer. And you can see that it's a nice HTML table, contains lots of information. Maybe the formatting isn't as beautiful as I want it to be, but you know what I could do is I could link that to a cascading style sheet. In fact, if we look at the help for convert to HTML, you see that I've got a body parameter and a head parameter that allows me to, as well as a title parameter, that allows me to insert more information into the HTML. I could insert some text that explains what the page is. Hey, this is a list of services you need to look at. I can insert enough into the head portion of the HTML to link it to a CSS file, a cascading style sheet that would apply formatting to the HTML. So I could, maybe have the header row be bold-faced and the other rows have grid lines between all the different cells. So you can do a lot of different work with the HTML once you've got it out. The key functionality is actually getting it into this HTML format. Convert to HTML will take almost any type of object. If we want to go back here, and before we convert it, let's just select a few of the properties we care about here. Let's maybe select the start mode, the state, and the name, and convert that to HTML. Now this time, when we look at the HTML file, maybe it'll be a little easier to read because it just has got those 3 columns with just the information we want. So the ability to export that information to XML is a great ability to have in Windows PowerShell. It's a great way to create fast little management reports. It's a great way to maybe schedule something, dump the file onto an intranet web server, make it available to other people in your organization. All in all, it's just another way of getting PowerShell objects into another format for maybe different uses. In this nugget, we looked at ways of getting objects into and out of Windows PowerShell, comparing them and converting them. We talked about exporting and importing to and from comma-separated value files. We talked about the CLI XML format, how we can save objects in an XML file and then sort of re-bring them back into the system or deserialize them back into the system and work with them. For example, to compare them to a baseline collection. We also looked at ways of converting objects to HTML, which is quite a good way to produce really fast, easy to make management reports in an easy to read and distribute format. I hope this has been informative for you, and I'd like to thank you for viewing.